All right, good afternoon, class. Okay, so the last two lessons we have learned what is complex number. Okay, how to do the addition, subtraction, multiplication, and division of two complex number, and how to use the properties of the equality of two complex number, and also the questions that involve the complex roots of the polynomial function. Right, like quadratic, cubic, quartic, and so on. All right, so today we will see 4.5 Argand diagram. All right, so what is Argand diagram? Okay, let's see number one. A complex number x plus yi, where xy are real number, can be represented as a point on the coordinates plane with coordinates xy. Remember before this we say complex number is an imaginary number. Those we cannot represent by real number line. Okay, but we can represent it on the Cartesian plan. Right, and this is a special Cartesian plan, of course. It's not the normal one that we have learned. All right, so for example, let's say I have one complex number with 2 minus i. All right, so I can write 2 minus i in the coordinate form as the real part x is 2 and the imaginary part y is -1. Or I can write it in this coordinate form, and I can represent this point 2, -1 on the Cartesian plan as this one. Alright, so it's just like the normal Cartesian plan that we use, alright, but the name of the axes are different. Okay, the horizontal axis represent the real part x, therefore we call it real axis. Whereas the horizontal axis represent the imaginary part y, so we call it imaginary axis. Alright, this is a different compared to the normal Cartesian plan. Alright, so the point 2, -1 is here. X is 2, y is -1. So this is a point represent the complex number 2 minus i on this Cartesian plan. Alright, so here are some history about this Argand diagram. Alright, a diagram in which the complex numbers are represented in this way is called an Argand diagram. We call this Argand diagram. Okay, it was introduced by a French mathematician named Jean-Robert Argand. So it's named by the mathematician who lived from 1768 to 1822. Not long life lah, 50 something. Okay, so this is Argand diagram. All right, and number two, on the Argand diagram, the real axis x are represented on the x-axis, and each unit on the x-axis represented by 1. This one. All right, and B, the imaginary numbers yi are represented on the y-axis. This one. And we call it imaginary axis. Each unit on the y-axis is represented by 1i. All right. Okay, number 3. So in the Argand diagram beside here, this one, okay, it shows the relation of a conjugate pairs on Argand diagram. Okay, let's say I have one point P represent the complex number z equals x plus yi. So this is complex number z. All right, and P bar represent the conjugate of z, which is x minus yi. Also notice that the position of the complex conjugate P bar is obtained by reflecting the position of P on the real axis. So this is the original z. So the conjugate just reflects about this real axis. So it becomes x and -y. Remember conjugate x are the same. So they're on the same horizontal line, vertical line, and y, one is positive, one is negative. All right, it's not difficult. Okay, so now let's look at checkpoint 4.1, page 190. Okay, so I'm going to discuss these 3 questions regarding Cartesian plan. All right, so page 190, checkpoint 4.1. Okay, this one. All right, so you can refer to your textbook. So I'm going to discuss question 5, 7, 8. All right, question 5, block the following complex number on a separate Argand diagram. All right, So this one, I think no problem. Can. All right. I have already tried one. All right. So I try number 5D. Okay. So question 5D. So you are given Z is -6 minus I square root 13. So when you involve surd, sometimes you see they can put the I here or sometimes they can put the I here. It's just that when you write, make sure you don't put your I in the surd. Okay, so this is wrong. It's supposed outside the surd. Then only correct. Alright, so draw this one. So very simple. As usual, block XY axis and the origin. Okay, so the X is -6. So here. And the Y is negative square root 13. So negative square root 13 is about 3 point something. So here. Alright, so this is a point. Represent this complex number Z. Alright, so we can just label. Alright, we can just label the coordinate. And actually we can draw a line from the origin, go connect to the point. Alright, so this is how we block Argand diagram. It's just that simple. But in STPM, yes, they do ask you to sketch a simple diagram like this. Alright, so make sure you know how to draw it. Alright, so the next one is question 7. Alright. Okay, so look at your textbook. Look at your textbook. Question 7 say ABCD is a square. Alright, with the letters in the anti-clockwise order. Anti-clockwise. ABCD labeled anti-clockwise. And you are given that points A and B represent 2 plus 3i and 6 plus I respectively. Alright. Okay. So find the complex number represented by C and D. Okay, very simple. So again, we block the graph, so easier for us to see. Okay, so the question give you A. Okay, point A is 2 plus 3i. So X is 1, 2. Y is 3. So 2 plus 3i. This is A. Alright, then B is 6 plus I. So X is 6, Y is 1. So this is B. Alright, so how the square looks like? Remember just now the question say ABCD is arranged in anti-clockwise. Anti-clockwise. So if here is A, here is B, anti-clockwise means going this way. Going this way, anti-clockwise. So A, B, C will be here and D will be here. Alright, so I block ABCD. Roughly because it's a square. So dot, 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 dot. Okay, I know C is here and D is here. Okay, how we are going to get the coordinate for C and D? Alright, we don't use calculation, we just use calculate the step. Alright, you see this gradient is horizontally 4 unit, vertically 2 unit. Alright, when it is 90 degree, so it's another way around. Means vertically 4, horizontally 2. Alright, so from this point, I move up 4. Alright, and from here, I move 2. So 4 unit, 2 unit. Alright, so horizontally, I move 2 unit. So originally is 6. So move 2 unit, 8 lah. Alright, and originally Y is 1. Move up 4 plus 4. So 5 lah. So this is how I get point C. Alright, so to get point D, similar, same thing. So from here, I'm going to move up 4 unit and horizontally 2 unit. Alright, so originally, this is 2. So move horizontally 2 also. So 2 plus 2, 4 lah. Alright, and originally this is 3. So 3 move up 4, 7. Alright, so I get the coordinate for point D, 4, 7. Okay, but the question wants you to find the complex number represented by C and D. Therefore, the coordinate for C is 8, 5. Therefore, C is 8 plus 5i. Alright, and the coordinate for D is 4, 7. Therefore, D represents the complex number 4 plus 7i. Alright? Okay. So, others question in 5, you do as homework. And question 8 also. Question 8 actually quite similarly to this thing. So you do it as homework. Alright. Okay, so this is roughly about Argand diagram. Alright. So since we can draw it on the coordinate plan, so means that it definitely involves modulus and argument, means modulus and anchor. All right, so next we are going to see what is modulus of a complex number and what is argument of a complex number. Okay, we use one example to explain it. All right, so let's say I have a complex number z, which is equals to x plus yi. All right, so I can represent this complex number by using a point on the Cartesian plan, xy, okay, x unit, y unit. All right, then I join from origin to the point. So I get this diagram. All right, modulus means the modulus of this complex number z, we can written as modulus z. And it is actually the distance of point P from the origin O. Means this line, OP. It's the modulus of this complex number. We represent it by small letter r. All right, so this is modulus. And how to calculate this modulus? We are using Pythagoras theorem. Pythagoras theorem. Therefore, r or modulus z is line OP. And by using Pythagoras theorem, line OP is x squared plus y squared and square root. Okay? Very simple. Okay, and other than that, let's say I square both sides. So when I square this one, I get this modulus z squared. And after I square this, the square root don't have. All right, and now we want to relate it to the conjugate. Remember, let's say if z star is the conjugate of z. So when we multiply a complex number to its conjugate, remember, it's x squared plus y squared, right? Yes, then you compare to this. From here, we can make one statement that actually the product of a complex number with its conjugate actually same as the square of the modulus. The square of the modulus of the complex number. We get this statement. All right. Okay, number 3. So now we know what is modulus, the length of this line. Now, what is argument? All right. So let's look at number 3. Okay, 3a. The angle of inclination of OP with the positive x-axis. Let's say it's theta. So it means that this is positive x-axis. This is line OP. All right, the angle inclination of OP and the positive x-axis is this angle. So we name this angle as theta. Okay, so this angle expressed in radians with domain, theta is between negative pi to pi. We normally write this angle in radian. Okay, and the domain is from negative pi to pi, means same like what we have done before. So this is 0 to positive pi. This is 0 to negative pi. All right, and the theta angle must be always the angle measure from positive x-axis to the line OP. Therefore, in this example, let's say if this is P, so this is the angle. All right, not this one. All right, not this one. So if the P is here, all right, if the P is here, then the angle will be this one. It becomes a negative angle. Okay? It always the angle between positive x-axis with the OP, with the line OP. All right? So first thing, make sure you know how to measure this angle. The angle between the line represent the complex number to the positive x-axis. All right, and B, so this theta, this angle is called the argument of the complex number z. So argument means angle between complex number z and the positive x-axis. All right, and we represent it by ARG, argument, so ARG of complex number z. All right, which is equals to theta. So from the figure above, from this diagram, okay, from this diagram or this diagram, easier to see. All right, so from this diagram, all right, we can see that this is the theta. So tangent theta, tangent is opposite adjacent, right? So tangent theta equals y over x. Therefore, theta is arctangent y over x. All right, therefore, argument of complex number z, which is theta, is equals to arctangent y over x. This is the formula to calculate argument. So this is the formula to calculate modulus. This is argument. All right. So note that this one you know lah ha, arc tangent lah ha. Okay, D. If tangent theta is equals y over x, so we'll give an infinite set of angles which satisfy this trigonometry equation, right? We have learned this one in trigonometry. So for example, if I say tangent theta equals 1, therefore your theta can be 45, 225, 405. So all this angle will give you tangent theta equals 1. Alright, so it means that this argument of z is a set of angles. It's a set of angles which satisfy this trigonometry equation. Alright, but the position of OP is unique. Means if P is here, so only one position of P is unique, only one, and corresponded to only one value of theta. So it's supposed only one angle lah. Alright, why we have repeated? Because it's again and again and again. Therefore, there is supposed only one value of theta in the range negative pi to pi. So this value of theta is called the principal argument of complex number z, and we write it as ARGZ. Now we use small letter a. Just now, if it is a set, then it's big capital letter A. Alright, so in our calculation or solving problems, we actually want to find this one. Okay, so this is just for your information. Alright, so therefore the argument of complex number z is actually referred to the principal argument, which is unique, only one. Therefore, argument of z equals theta will be arc tangent y over x. Alright, while the capital A argument z is an infinite set of arguments like this. Okay, so note that the argument is sometimes give the alternative name amplitude. Means some other reference book, especially the overseas reference book, maybe they use the word amplitude. Alright, but in Malaysia, STPM, we are using argument. Alright, don't worry. So now you know, you have the concept. Alright, first, how to represent a complex number in Argand diagram. And from the Argand diagram, we can calculate the modulus OP of a complex number and also the argument of a complex number, which is the angle measured from line OP with between line OP to positive x-axis. It must be positive x-axis. For example, this is a good example. Positive x-axis and line OP. So not this one. This is negative x-axis already. Alright, okay. Let's see some example which related to modulus and argument. Alright, so let's look at example 4.68. Alright, question 1. We do a very simple question. First, so question 1. Alright, so if W is 1 plus square root 3i, find the modulus of W and the argument of W. So just apply formula. This is W. So modulus W is square root 1 square, 3 square. Right, just like this. So it's 4. So square root 4, 2. So the modulus is 2. The line OP is 2 unit. And the argument is arc tangent y over x. So this is y. This is x. So y over x. Alright, so arc tangent sub 3 is 60 degree. So pi over 3 radian. Remember we write in radian. Alright, question 1. Alright, question 2. Okay, so question 2 is STPM 2018. They can just ask a very simple question like this. Alright, you are given a complex number z. And this complex number has modulus 8 and argument 2 over 3 pi. Just now question 1, we find modulus and argument. Now this question, they give you modulus and argument, and they want you to find the real and imaginary part of z. So 3 marks only. Okay, so actually to solve this question, we have 2 methods. One is by using polar form. Remember at the beginning of this chapter, I told you that complex number can express in 2 forms. Alright, now this one is Cartesian form, and another one is polar form, which involve sine and cos. We haven't go to this one yet. So later when we go to polar form, I will explain this question again to you, how to use polar form to solve it. All right, so we are going to use the second method, where since they give us the modulus and argument, so we use these two concepts. All right, okay. So your given modulus is 8. So formula for modulus is square root x squared plus y squared. We don't know what is z, we want to find z, right? So maybe we'll start with let z equals x plus yi. Start with this. Then modulus is x squared equals 8. So I square both sides, so I get equation 1. Alright, then after that we use the concept for argument. Alright, so the question tell you that the argument is 2 over 3 pi. And formula for argument is arctangent y over x. Alright, therefore y over x is tangent 2 over 3 pi lah. 2 over 3 pi is 120 degree. So 120 degree is in second quadrant, remember? Second quadrant. Alright, therefore tangent is negative. Alright, tangent 120 is sub 3 lah, so negative. Alright, so I get y is equals to negative sub 3x. So I name it as equation 2. Just now equation 1 is here. Okay, now sub equation 2 into equation 1. So just sub in. Okay, expand this one. So you have 3x squared plus 1x squared, 4x squared equals 64. So x squared equals 16. So x equals plus minus 4. Alright? Okay, why we reject x equals 4? Because just now remember, we know that the argument is in second quadrant, 120 is in second quadrant. Alright, so second quadrant means, okay, here. Alright, this is x, this is 0. Second quadrant means here. So second quadrant, this side x is negative, right? Okay, x must be negative. Therefore, we only accept this one, we reject this one. Because argument z equals 2 over 3 pi means it's in second quadrant. So in second quadrant, x must be negative. Alright, so when x equals negative 4, sub in here, so I get y is 4 sub 3. Okay, but the question asks you to find the real and imaginary part, right? So don't stop here lah. Remember to write this. So real part of z is negative 4 and imaginary part of z is 4 over 3. Alright, if you want to write it again, z is equals minus 4 plus 4 sub 3i, also can. Alright, okay, so this is question 2, which is STPM 2018. Alright, can Okay, so we have finished this. Actually, it has some other parts, but we haven't go through that one yet. So we just discuss A first. Okay, so one more question. 3. This is STPM 2008. Okay, you are given z is a complex number such that the modulus is 1. So this one, they only give you modulus. Find the real part of this complex number. So this is another complex number. 6 marks, means this one longer. Alright? Okay, so let's say, we don't know what is z, right? So let's say z is x plus yi. Alright, and you're given modulus z is equals 1. So modulus, you know how to calculate, right? Use the formula x squared plus y squared, square root lah. Square root x squared plus y squared equals 1. So we square both sides, so we get this one after square both sides lah. Okay, I directly write. I skip one step. Okay, so now they want the real part of this complex number. Okay, so we start here. 1 over 1 minus z. Alright, and just now we say z is x plus yi so 1 minus x plus yi. Alright, then we simplify this. So 1 minus x is the real part minus yi. So real part, imaginary part. It becomes like this. Alright, so remember division so we multiply the conjugate so that we're realizing the denominator. Alright, so multiply with each conjugate. So each conjugate is minus become plus 1. Okay, so when multiply one conjugate pairs, remember, so just the real part square and the imaginary part square plus. Alright, what else? The numerator, 1 multiply this one, same lah. Okay, so we elaborate it. Numerator, we make it like this. denominator. So 1 square x square. Or 2 multiply this one is minus 2x. Right? So from here you see or not? I get x squared plus y squared here. What is x squared plus y squared? Yeah, just now we already show x squared plus y squared is actually 1. This is actually 1. So 1 plus 1. 2 lah. 1 plus 1, 2. 2 minus 2x. Numerator still the same. Okay? So, after that, I have to split into 2 ma. X plus yi ma, 2 part. Real part and imaginary part, right? So, this is a real part. 1 minus x. And the denominator, I factorize it. I factorize out the 2. Alright, then imaginary part is this one. Okay, so after I factorize, you see or not? This one can be simplified. Left halved. So this 1 over 1 minus z is actually equals half plus y over 2 1 minus xi. Alright, and the question 1, the real part. So the real part of this complex number is half. Alright, so it gives you 6 marks, a question like this. So when you see something like that, don't be afraid. Just continue what you know. Okay, use the method that we know to continue it. Alright? Okay, so these are some questions which related to modulus and argument. Okay, so let's continue. Number 4. So when working with arguments, the anchor, it is always wise to draw an Argand diagram to get the correct answer. Alright, so what does this mean? So when you are doing with argument, so it's actually better for you to draw. Okay, to draw one Argand diagram so that you can find your argument correctly. Okay, so what does this mean? I will show you with some examples. Then you understand. Okay, so next we will go to alright, this. Okay, still can see it. Alright. Okay. So questions, example 4.6b. So question 1. You are given W is 1 minus 6i. Find the modulus and the argument. Alright, so this is W. So no problem for modulus. Just 1 square plus 6 square. 1 and 6. Okay, so it's square root 37. Okay, now argument. Alright, so argument of W is equals arctangent y over x. So y is negative 6. X is 1. Alright, so let's see. When you press calculator. So let's check. Where is arctangent? Okay, here. Okay, can see. Let's say if I press arctangent. Okay. Negative 6 over positive 1. Alright, can see? Okay. So, next. Okay, close the bracket. See that? Arctangent, negative 6. So, I press equal. So, what is this? Negative 1.40. The answer is in radian. Okay, they give you the answer in radian. So it's negative 1.4056. Okay, negative 1.4056. Negative. Okay, so this is still okay. You don't see it. Later I will tell you. Alright, so you see for tangent negative have 2 quadrant. Remember? For tangent negative, you have 2 quadrant. Either second quadrant or fourth quadrant. Remember? So tangent negative has 2 quadrant, either in second or fourth. So how I know? This W is not in fourth. Alright? This is the thing that will confuse you. Okay? Because this calculator is more advanced lah. So and because I press 6 at the numerator, so they give me this answer. But how about if my W is here? If my W is here, when I press the same thing, they give me the same answer. But actually it's not, right? Or later I will show you question 2. Then from there you will see. Okay? So if I sketch the Argand diagram, so X is positive 1, Y is negative 6. So positive 1, Y negative 6 is in this quadrant. So when I see that complex number W is in here, so definitely the argument is a negative anchor. With the diagram, you won't make mistake. Okay? Okay, let's look at one more question. This one you will see. Question 2. Find the modulus and argument for the following complex number. So I given you 4 different complex number. But you see that the integer actually same. The digit just the sign different. The negative positive sign different. It's all X is 4, Y is 3. 4, 3, 4, 3. Alright? So A. This one. So the modulus for it, no problem. 4 square plus 3 square, which is 5. So modulus for all the 4 complex number are the same, 5. Alright? So when come to argument, so I sketch the diagram first. When come to argument, so this is 4 and 3. So it's here in first quadrant. So definitely I know that it is positive, right? So this one, no problem. If both X and Y are positive, no problem. You just press calculator. So the argument for this one is arctangent Y over X, or Y over X. Alright? So you see, I press arctangent. Okay? What? 3 over 4. 3 over 4. Right? So it's 0.6435. Alright? So 0.6435 positive. No problem. Alright? This one safe. Okay, now look at the second one. Look at the second one. Alright? B. Negative 4 plus 3i. Modulus is 5 as I say, same. So when I block the Argand diagram, okay, when I block the Argand diagram, I will see that the complex number is here. Alright, so the argument suppose a positive anchor. Alright, so when you just press calculator, now you see argument for this one is arctangent Y over X. Alright, Y over X. So let's see. Now delete. Cannot go back. No. Okay, never mind. We do again. So arctangent. No. Okay, arctangent. Alright, now is 3 over negative 4. So 3 over negative 4. Okay? So let's see. See? What they give you? They give you negative anchor. See or not? They give you negative answer. Alright? But suppose, they give you negative answer. See or not? But suppose we know that this complex number is here. And here suppose is a positive anchor. And now you see or not? Yes, it's very important. Don't just press calculator. You must have Argand diagram, then only you get the correct answer. If you just press the calculator, yes, the calculator will give you the wrong answer. It becomes negative anchor. Alright? So how to get this anchor? How to get this anchor? Okay, so one of the method that I can tell you is, so when you press your calculator to find the arctangent, alright, don't press any negative sign. Even though it has negative, don't press. Alright, so for example, first when you write your solution here, you still write 3 over negative 4. But when you press calculator, alright, you don't press the negative, you press 3 over 4. 3, okay, wrong. Correct. You just press 3 over 4. Don't press the negative. Equal answer. Alright, this one give you the acute anchor. Still remember acute anchor? Yes, this one give you the acute anchor. Alright, 0.6435. Okay, so you get the acute anchor. Alright, you get this acute anchor. So you know that this anchor is in second quadrant. So to find this anchor, the acute anchor 0.6435 is here actually. They are giving you this. Alright, so to find this one is pi minus 0.6435. Remember how to find this anchor? Still remember when you learn in Trigo? So therefore, the answer is, okay, pi minus answer. So where is your pi? Okay, pi is here. So plus shift, the pi is here. This one. This one. Okay. Okay, see or not? Pi. Okay, minus just now answer. Alright, so it's 2.4981. 2.4981 radian. This one you have to write RAD. Okay, this one you need to write RAD because it's in radian. Okay, just now, radian. Just now one question we don't write RAD is because, let me check. This one. Just now this one. The argument of W is equals pi over 3 because it's in terms of pi already. We know pi is radian, right? So if in pi, then you don't write radian, it's okay. Alright? But if it is not in pi, then you have to write. Okay? Is that clear? So remember, whenever you are asking to find the argument, first, draw the Argand diagram and see where is it. Then you press the calculator at tangent y over x. So when you write here, yes, you can write the negative. But when you press the calculator, please don't press the negative. Alright, so that you will get the acute angle. When you get the acute angle, then you see how you want to find the angle that you want. If it is in first quadrant like this, no problem. The first quadrant, straight away is the acute angle. If it is in the second quadrant, then it's pi minus the acute angle. Alright, okay, let's see the third one. Minus 4 minus 3i, so modulus same. Okay, so my negative 4, negative 3, so it is in third quadrant. Alright, so argument is at tangent negative 3, negative 4. So definitely when you type your calculator at tangent negative 3 over negative 4, they will give you this answer. Definitely they will give you this answer, which is wrong, right? So you see that if in this quadrant, the anchor supposed is negative anchor. Alright? Therefore, how to get this? Very simple. You know that the anchor is like this, right? So you know that it is a negative anchor. Then, how to find this anchor? Same like this one. Because the whole thing is pi. So pi minus the acute angle that showed to you. So pi minus 0.6435. But you know that it is a negative angle. Alright? Therefore, the answer is negative 2.4981 radian. Same like this one, but negative. Alright, so I hope with this with this diagram, with this question, you see very clear. So again, I repeat, to find argument, first, please draw your Argand diagram. Label correctly lah. Okay, second, calculate your arctangent. In the solution, you can write your positive negative sign. But when you press your calculator, please press all the positive only. And remember, the calculator will give you the acute angle. Alright? So you see the angle is in which quadrant? So that from there, you know how to determine the correct argument. Alright? So the fourth one. Modulus still the same. So this is 4 minus 3i. So x is positive 4, y is negative 3. So it's in the fourth quadrant. Alright, so argument is arctangent y over x. Alright, so again, when you press 3 over 4. And they will give you this acute angle. Alright, and you know that it is in fourth quadrant, so the angle is negative. Alright, and this is the acute angle. Okay, so I hope it is very clear. Alright, by using this second question. Yes, you really have to determine your argument correctly and carefully. Alright? Okay. So, the next one. Alright, so today, just one quiz only. Alright, just one question. STPM 2005. Correct. One question only, right? Argand diagram. Okay, yeah, just one quiz only. So after you finish this lesson, please do this. STPM 2005. Okay, you are given complex number Z1, Z2, satisfied this equation. Remember, express Z1 and Z2 in the form A plus BI. 6 marks. We have done. I think I asked you to do it as quiz. Let me check. 205. Yes, here. See? Yesterday. Yesterday. Yep. Yesterday. You have done this one as your quiz, so you can check. Alright? So you do again. First part you have done. So you can refer back. Then second part, represent Z1 and Z2 in Argand diagram. You see, as I say, you got your Z1 and Z2 here already, so they want you to draw it in the Argand diagram. 1 mark. Everything must be correct to get this 1 mark. Alright? Then for each Z1 and Z2, find the modulus and the argument in radians. So just do what you have to do. Okay? Alright, so this one STPM 2012, you are given complex number Z, find modulus and argument. This is very simple. So you do it as homework. Okay, so other than that, please complete your checkpoint 4.3. Alright, checkpoint 4.3, you complete all these questions. Question 1, question 2, AC, question 3, A, D, C, question 4 to question 7, all related to modulus and argument. Alright, so today's lesson, I will just stop here. Okay, so tomorrow we will continue complex number in polar form. We have finished complex number in Cartesian form. Okay, next we will see complex number in polar form. Alright, okay, see you tomorrow. Bye.